Alright, so today we are going to go over the review sheet for Unit 4. So the first one, factor by grouping. Since I have 4 terms, I am going to group the like term together and take out anything that I can. So I'm going to group these first 2 together and say, what do they have in common? Well, they both have a 2 and they both have an x. So I'm going to bring that 2x out to the front. If I factor a 2x out of 2xy, I'm left with a y. If I factor a 2x out of a 2x, I'm left with a 1. My second grouping is going to be this 5y minus 5. So I'm going to bring out what they have in common. So they both have a 5. And if I take a 5 out of a 5y, I'm left with y. And a 5 out of a 5, and I'm left with 1. Because now both terms have an x minus 1, sorry, a y minus 1, I'm going to bring this y minus 1 out to the front. So if I take a y minus 1 out of the first term, I'm left with 2x. If I take a y minus 1 out of the second term, I'm left with plus 5. So that is my factoring. Right here, I can do the same thing. I'm actually going to take an x out of these first 2. So if I take an x out of a 2x squared, I still have a 2x. If I take an x out of a 7x, I have a 7. I'm going to group my second 2 together, and what do 6x and 21 have in common? Well, 6 and 21 are both divisible by 3, so I'm going to go ahead and bring a 3 out. If I take a 3 out of a 6x, I'm left with a 2x, and if I take a 3 out of 21, I'm left with 7. So again, just like on this first one, we can see that both of my terms now have a 2x plus 7, so I'm going to go ahead and pull that out to the front. If I pull that out to the front, so if I take the 2x plus 7 out of here, I'm left with an x, and out of here, I'm left with a 3. So that is my factored form. And on this next set of problems, we are going to factor it, and then we're actually going to solve it. So I will find what the values of x are that make it 0. So right here, I need this to be in standard form, so I need to go ahead and add this 14 back to the other side. So this is a simple trinomial. I do not have a coefficient of the x squared term, so what I'm looking for are what factors of 14 will add to give me 9. So if I write my factors, which of those add to give me 9? Well, a 2 and a 7. They're going to add to give me a negative 9, so that lets me know that both terms are going to be negative. So that is factored form. So now for my solutions, I'm going to set each piece equal to 0 and find out what x would have to be. So right here, I need to go ahead and add the 2. And right here, I'm going to add the 7. So those are my 2 solutions. On this next one, I do not have 3 terms. I have 2 terms, which means I'm probably looking at a problem where it's the difference of perfect squares. 121 is a perfect square, x squared is a perfect square, and 81 is a perfect square. Because I'm subtracting in between, I know that that's going to leave me with factors where 1 is positive and 1 is negative. To get my actual terms, what is the square root of 121x squared? 11x. What is the square root of 81? 9. So this is my quadratic in factored form. So now, to get my solutions, I'm going to set each piece equal to 0 and solve. So over here I'm going to subtract 9 and then divide by 11. Over here I'm going to add 9 and divide by 11. So those are my two solutions. On this fourth one, if I look at this, I have 3 terms, so it is a trinomial, but if I look, I have a cubed term. But when I have a trinomial, the first thing I want to look at is, do they have a GCF? Do they all have something in common that I could take out? If I look at all 3 of my terms separately, they all have an x, and they're all divisible by 2. So I'm actually going to pull a 2x out first. When I do that, I'm left with x squared minus 9x plus 20. Now I have a simple trinomial where my coefficient of my x squared term is in fact 1. So when I look at this, I'm looking at what factors of 20 add to give me 9. So if I list my factors, I need the 2 that add to give me 9. So I still have this 2x on the outside, but they're adding to give me a negative 9, so I know both of them should be negative. So there is my factored form. Now when I find my solution, since my original was a cubic, I should have 3 solutions. So do not forget to set this 2x equal to 0. So right here, if I divide by 2, that's still just going to give me 0. Right here, if I add my 5, and right here, if I add my 4, get rid of x. Okay, so those are my 3 solutions. Now this last one is a trinomial, but I do have a coefficient on my x squared term. So when that is the case, I need to do a times c to get my number that I will be looking for factors of. So I'm looking for what factors of 6 subtract to give me 5. So since the c term is negative, I'm looking for which ones are going to subtract to give me 5. So if I list my factors, they need to subtract to give me 5. Since the middle term is positive, my larger factor will carry the positive. Now, remember that we can use the box method to actually factor this out. So I know I have a 2x squared, and now I'm going to break this down into the 2 terms that I just found. Now over here, if I'm looking at 2x squared and 6x, what do they have in common? They have a 2x. Now if I look at a negative x and a negative 3, they have a negative 1. Now let's look down. So I have a 2x squared and an x. They both have an x in common. And I have a 6x and a 3. And they have a 3 in common. These become my factors. So 2x minus 1 and x plus 3. So there is my factored form. Once I have factored form, I can set each factor to 0 to get my solution. So here I'm going to add my 1 and then divide by 2. Over here I'm going to subtract my 3 and I get negative 3. Okay. Alright, moving on. So simplifying radicals. So when we have radicals and we are trying to simplify them, remember that we are trying to break them down into their prime factorization. So there's a couple different ways that we can do this. I'm going to start with 242 and I just start dividing by my prime numbers. Well, once I get here, I know that this is 11 and 11. So when I rewrite this, I'm looking for pairs. So remember, if I have a pair, I can bring it out. So I'm left with 11 square roots of 2. Okay? Anytime I have a negative, the first thing I want to do is I want to go ahead and get rid of that negative by pulling out the imaginary, the I. Now I'm left with 28. I can break down my 28 the same way I did over here. So now if I rewrite, I have 2 times 2 times 7. And remember, I'm looking for pairs so that I can bring it out. So in this case, I can bring out a 2. So I have a 2i, and I'm left with my square root of 7. Now, when we are multiplying, there's a couple different ways we can do this. We can simplify first, so that way we have smaller numbers, or we can simplify at the end. It does not matter. So I'm going to do my coefficient times my coefficient, and my square root times my square root. So 8 times 42 is going to give me 336. And now I need to break down my 336. So if I just break this down into my prime factorization, I keep going until I get it as far down as I can. And then I'm going to go ahead and rewrite it. So I have 1, 2, 3, 4 2's. So 2 times 2 times 2 times 2. And then I have the 3 and the 7. But remember, I'm looking for pairs. So here's a pair of 2's, and here's a pair of 2's. So I actually get to bring 2 pairs out. So I have 12 times 2, which gives me 24. And then I have 24 times 2, which gives me 48. And then I still have a 3 and a 7 underneath, so a 21.